And welcome back. This is our video solution to problem 3 from our first quiz. In this problem, we're given a second order differential equation. So remember, the second order just means that the highest derivative you see is a second derivative. And just as in problem 2, we're given a solution, right? A general solution to this differential equation. You don't need to figure it out yourself here. And it looks like basically some sort of combinations of sines and cosines plus some extra constant, b, which, okay, that does show up in the original differential equation. And just as in problem 2, we're trying to find a particular solution, only now because there are two different constants, right, that tell you have a general family, right, namely the C1 and this C2. The A and B are just some given constants, right? They're not going to vary, right? There's no family there. But given you have these two constants, it's not actually too surprising. You need two different initial conditions in order to determine those constants. And in this problem, we've been given two initial conditions, namely that at 0, the function y takes on the value 2, and also at 0, the derivative of y takes on the value 1. So we'd like to use these two data points in order to find values for C1 and C2 so that we have a particular solution for the original differential equation. All right, and you notice here this little note, your answer should include A's and B's. Again, those are some given constants, right? Maybe that's something that's experimentally found or something, right? We don't know what those numbers are, but they're not going to really play a significant role in this problem. They just kind of float around annoying us because we have to write them. All right, but let's see how we get to this. So first, we know that 2 is equal to y of 0. And we can just plug this 0 then in for t in this equation for y. So we're going to get C1 times the sine of a times 0. And let's pause there and note, hey, a times 0 is 0. And you're going to have to know that for this class, the sine of 0 is 0. Okay, so actually this whole sum end is going to go away. Plus, then we get C2 times the cosine of a times 0. And, well, a times 0 is still 0, but the cosine of 0 is 1. So this whole sum end is just going to be C2 plus whatever this b is. Now, our goal is to solve for the coefficients C1 and C2. So we can solve for it here, right? C2 times 1, that's just C2. We can subtract the b, and we'll get 2 minus b is equal to C2, right? Because this whole sum end goes away because it's C1 times 0. Okay, cool. So we found C2. So it means we need to find C1. Well, how are we going to do that? Well, we'd like to use this other data point, but it's something about the derivative of y. And what do we know about the derivative of y? Well, we know what y is, so we can compute the derivative. Let's just do that. Y prime of t equals, okay, we're going to differentiate. Now, this C1 is a constant, so I can copy that. Then I have a derivative of sine. That's going to be cosine. Of AT, ooh, but of AT, this is a chain rule situation. I have to take the derivative of AT, which is just going to be an A, which I'll pull out to the front. All right, moving on. I'm going to have plus C2. Now the derivative of cosine, oh, that's negative sine. So that turns into a minus, and then I have sine of AT. And again, by the chain rule, I get another A to come out. Okay, then I take the derivative of b, but b is just a constant. So that's just going to be 0. Okay, well, I now have y prime, and I have this initial condition. So let's put it all together. 1 is equal to y prime of 0. Okay, what is y prime of 0? Well, it's just this, but t gets replaced by 0. So I get a times c1 times the cosine. Well, this is the same situation we had before. This is going to be the cosine of a times 0, and that's just going to be 1. Minus ac2 times the sine of a times 0, and again, sine of 0 is 0. So this second sum end is going to go away, and I'm just left with a times c1. Okay, and that's equal to 1. So I can solve for C1. I just divide by A. As long as A is not 0, then this is going to make perfect sense. So we better assume that, right? We'll just write that down. All right. We found C2 and we found C1. Now they're only written in terms of A's and B's, but heck, that's what it told us, right? Our answer should include A's and B's. So let's put this together then. Our particular solution is going to be y of t equals, I replace C1 with 1 over A, sine of AT, plus, okay, our C2 is 2 minus B, cosine of AT, and then plus B. And there we go. All right. Hey, I told you it's always going to be easy in hindsight, right? Maybe it's not easy going forward, but backward, hey, that doesn't look so bad. Okay, so whenever you're given a family of solutions to a differential equation, and that means you're generally going to have these constants, you usually need to have one initial value for each of the constants, right? If you're going to try to solve it. If they give it to you in terms of not just the original function, but maybe its derivatives, well, then you might as well take some derivatives, all right? And that's going to help you plug these given data into your y's or your y primes, and that'll help you find your constants. All right, we'll see you next time.